Good day, sir. So today I will present to you my third recorded video recitation, which about to rotation and dynamic of rotation. So the problem is, consider the father pushing a playground merry-go-round and figure. He exerts a force of 250 Newton at the edge of 50.0 kilogram merry-go-round, which has a 1.50 meter radius. Calculate the angular acceleration produced for letter A when no one is on the merry-go-round, and for letter B when an 18.0 kilogram child sits 1.25 meter away from the center. Consider the merry-go-round itself to be uniform disk with negligible retarding friction. In this problem, I use the formula of T is equals to inertia times alpha. And also by manipulating this formula, in order to get the value of angular acceleration, I use the formula of alpha is equals to torque over inertia. So, para makuha yung value ng angular acceleration, we must have first the value of torque and the value of inertia. So, first kinuha ko is the torque. So, I use the formula for the torque. T is equals to radius times force times sine theta, which equals to 1.50 meter times 250 Newton, which results to the value of torque, which is equals to 375 meter times Newton. So after getting the value of torque, so I was also required to get the value of inertia. So for getting the value of inertia, I have the given of mass is equals to 50.0 kilogram and radius is equals to 1.50 meter. So para makuha yung inertia, I use the formula of inertia is equals to 1/2 times mass times radius squared. And then substitution lang ng mga given. So we have 1/2 times 50.0 kilogram times 1.50 meter squared, which results to the value of inertia, which is equals to 56.25 kilogram times meter squared. Since meron na po akong value ng inertia and meron na rin po akong value ng torque, so pwede na po ako mag-proceed for calculating the angular acceleration for letter A when no one is on the merry-go-round. So para makuha yung angular acceleration, so I use the formula of alpha is equals to torque over inertia, which equals to the value of torque, which is 375 meter times Newton, divided by the inertia, which is 56.25 kilogram times meter squared, which results to the value of the angular acceleration, which is equals to 6.67 rad per second squared. So this is our final answer for problem letter A. So let's proceed for problem letter B. So since meron na po tayong torque, I proceed for calculating the inertia of a child. So we have the given value of mass is equals to 18.0 kilogram and radius is equals to 1.25 meter. So para makuha po yung inertia of a child, I use the formula of I sub c is equals to mass times radius squared, which equals to 18.0 kilogram times 1.25 meter squared. So our inertia of a child is equals to 28.13 kilogram times meter squared. Then after that, to get the value of the inertia, so I simply get the summation of those inertia from letter A and the inertia of a child by simply adding those. So the inertia is equal to 28.13 kilogram times meter squared plus 56.25 kilogram times meter squared, which results to the value of inertia is equals to 84.38 kilogram times meter squared. So since meron na po akong value ng torque and meron na rin po akong value ng inertia, so pwede na po ako mag-proceed for calculating the angular acceleration for letter B when an 18.0 kilogram child sits 1.25 meter away from the center. So Para makuha yung angular acceleration, I use the formula of alpha is equals to torque over inertia, which equals to the torque 375 meter times Newton divided by the inertia 84.38 kilogram times meter squared, which results to the value of angular acceleration, which is equals to 4.44 rad per second squared. So, this is my final answer for problem letter B.